So far, we have seen how to print things on the screen. The next question is, how do we store data inside our programs? And that's where variables come into play. A variable is a memory location whose content can be filled and changed during program execution. Think of a variable as a box within which you can put stuff and change later. Each variable must have a name and a type in C++. So here's an example. The blue thing, number num1, is the name of the variable. Integer, int, is the type. Int represents a natural number that you can put into this box. So you can put, like, natural numbers like 57 minus 5, 0, 1000, whatever. Think of any natural number that you can put. Of course, there is a range of values, range of natural numbers that you can put in there. So you cannot put like very large numbers within this box, and we'll talk about that later. Another variable type is double, which represents real numbers. This example, we have got a variable type double. The name of the variable is pi, and what we store in the box is 3.14, right? The pi value number. So another variable type is character. The name of the variable is letter, and here we are storing characters like A, B, C, Z. Think of any other character, question mark, star, that you can put in here. Another one is a Boolean type. The type of the variable is bool. The name of the variable is valid, and we can store either true or false in this variable. And lastly, we have got strings. The name of the variable is name. The type is string. I can store a sequence of characters enclosed within double quotes. So I have John being stored. The basic format for declaring variables is you put the type of the variable at the beginning, then you put one or more spaces in between, then the name of the variables, variable name 1, comma, variable name 2, comma, and you terminate the same statement with a semicolon as you would any other statement in C++. So here's an example. We've got our integer variable num1, so integer space num1. There could be more than one spaces between the type of the variable and the variable itself. And if you would like to declare multiple integer variables, you could say num1, comma, num2, comma, whatever the name of the other integer variables might be. This is our second variable, double pi. Character letter, bool is valid, string name. C++ is a statically and strongly typed programming language, which means after a variable is declared to be of a particular type, its type cannot be changed afterwards. So you've got num1 of type integer. Let's say you would like to redeclare num1 to be of type double later on. The compiler is not going to let you do it. But the alternative is a dynamically typed programming language exemplified by Python and JavaScript, where you could, for example, assign a value to num1, an integer value, and later on you could change. Here is the list of primitive or basic data types in C++. So the first one is bool, where you can store true or false values, occupies either 1 bit or 1 byte, depending on how it is declared. The next one is a character data type, which occupies 1 byte in memory. And usually you want to store a single character in it, such as A, B, Z, question mark, star, or whatever. What the character type is actually a 1 byte integer. So what actually is stored in a character variable is a number between minus 128 and 127, as we will see later. The next basic data type is short. Again, it's also used to store integers. It occupies 2 bytes in memory. And the range of values that you can store in a short variable is from minus 32,000 to around 32,000 plus 32,000. The next one, again, to store integers is integer and long. Interestingly enough, C++ variable type long is an integer. It's not an 8-byte variable as you would see in Java. So it's an integer long. The number of, the range of values that you can store in a integer or long variable is from like minus 2 billion up to 2 billion. Then finally, to the last variable in this category is a long. which occupies 8 bytes in memory, and you can store a larger range of values in an 8-byte integer. Then we've got two floating point numbers. The first type is float that occupies 4 bytes in memory that can only store a certain range of floating point values with 6 or to 7 decimal digit precision after dot. And finally, you've got double, which occupies 8 bytes in memory that can store both numbers with more precision and a wider range of values. In this class, we'll mostly be using bool, character, integer, and double. We will not be using short, long, or float. But I just wanted you to have this information that these also exist within the programming language in case you might encounter them somewhere else. Variable names in C++ must consist of letters, digits, or underscore characters as follows. The first character of the variable must be either a letter or an underscore character. So let's look at valid variable names. Fahrenheit, look at the first character of the variable is F. Celsius, it is C. Sum, it is S. A, 1, 2, 3. The first character is a letter, as you can see. Then it might have digits in it. So I1, again, the first letter of the variable name is a letter. Total sum, you can see that underscore is part of the variable name. Num students, again, underscore is name of part of the variable name. And a variable name can start with an underscore. So you can have underscore local variable. Although, this is not very common, but it is possible. The identifier or the variable name can be in lowercase or uppercase. You can see we have sum all in lowercase and sum all in uppercase characters. Upper and lowercase characters may be mixed, so you can have these three variables where uppercase and lowercase characters are mixed together. Finally, variable names are case sensitive in C++ and in many of the other programming languages, which means you're seeing some, and some. They are all different variables as far as the compiler is concerned because they consist of different, capital and lower letters if you look at them. So they are not exactly equal to each other. What are the variable names that you cannot declare? Variable name cannot have spaces in it, so total space sum is not a valid variable name because a variable name cannot have spaces in it. A variable name cannot have hyphens in it, so total hyphen or minus sum is not a valid variable name because minus, the minus sign, has a specific other meaning in C++. It is the subtraction operator. A variable name cannot have double quotes in it. Remember, in C++, double quote is used to define a string literal. That's why you cannot put double quote inside a variable name. A variable name cannot start with a digit, so 3x is not a valid variable. Remember, the first character of a variable must be either a letter or underscore, so this is not a valid variable name. Finally, keywords, C++ keywords cannot be used as variable names. What we mean by keywords is data types such as integer double, or as we will see later on, if, while, for. These are keywords that have specific other meanings in C++, so you cannot use them as variable. Finally, let's look at some variable naming conventions. Snake case. Let's say you have a variable that consists of 3 words. My variable name. If you put underscore characters to separate these words from each other within the variable name, it is called a snake case, and that's the C convention. C++ also widely makes use of this snake variable naming convention. Remember, C is typically used by embedded system developers, so system programming. So you would see in a lot of these system programming, system programs written in C, snake case being used as the variable naming convention. The second variable naming convention is camel case, which is adapted by Java. What they do is the first character of the variable, the first character of the first word, which is my, starts with a lowercase character, Then every other word within the variable starts with a uppercase or capital character. So my, capital V, and capital N. So my variable name, you see that V is capital, N is capital. So this is Java convention. Another convention is Pascal case, where every word starts with a capital letter, and this is the convention adopted by C sharp. Finally, you've got kebab case, which is where every word is separated by this minus or hyphen sign. Obviously, we know that hyphens cannot be part of a valid C++ variable name. So this is usually used by HTML and CSS. So it cannot be used by programming languages. The naming convention, variable naming convention that you pick for yourself has got nothing to do with the compiler. So to the compiler doesn't care which naming convention you use. It just takes a variable name and processes it. These variable naming conventions are typically adopted by different, organizations or by different programming languages to be consistent, to have some sort of a consistency across, different libraries and stuff. So my advice to you is pick a convention for yourself. If snake case is something that you like, you could pick it. My convention is camel case, so I usually, write this is what I use, my variable, and this is the convention that I use in my programs. But whatever convention you pick, of course, obviously you cannot pick kebab case. You have to pick up one of these three cases. Doesn't really matter as far as the compiler is concerned. When you define a variable in C++, its initial value is undefined. Here we are declaring an integer variable, integer num1. So here is the box. So the question is, what is the initial value of this variable? And in C++, it is undefined, meaning that it could be an arbitrary value. So let me show you that. So here is a program where I declared two integer variables, num1 and num2. The name of the file is ex1.cpp, so I'm going to compile it. Here it is. And now let me execute this and so that you can see what we see as the output. So I'm printing number one and number two without assigning any values to them. So as you can see, when I execute it, num1 is an arbitrary value, num2 is an arbitrary value. Let me execute it again. You're going to see that each time I execute the program, num1 and num2 have arbitrarily different values. So bottom line is when you declare a variable and do not initialize it, do not assign any value to it, you cannot make any assumption as to what the initial value of the variable would be. You have to initially, you have to initialize this variable before you can actually start using it. Given that the initial value of a variable when declared is undefined, how do we initialize it? How do we put values into this variable? To do that, we use the assignment operator, which is an equal sign in C++. So here is how you do it. Integer num1, this is your declaration. Then you say num1 is equal to 57. Don't think equality as the mathematical equality. What we're doing is an assignment operator. So what we're doing is we're taking 57 and putting it into the box that num1 is referring to, in a sense. So this is our box that num1 is referring to, and we are putting 57 into it. It is also possible to define and initialize a variable at the same time as follows. So you could say integer num2 is equal to 75. So what we did here was instead of just first declaring the variable and then initializing it, we basically combined these two statements into one, where we declare the variable and initialize it. Here is an example program. This is under O2 data types ex1.cpp, where I declare a variable of every primitive data type in C++, starting with bool. So bool is valid is equal to true, and declare and initialize it at the same time and then print it on the screen. So this is boolean. Let me actually go to the program. So here is the program ex1.cpp. Again, this is under O2 data types. So that's where you need to go. So boolean is valid is equal to true. I'm going to print that value on the screen. Character, letter, capital A, short value minus 57. Remember, these are the range of values that we can store in a short variable. This is the range of values that we can store in the integer. So I'm saying integer num1, and this is the value that I assigned. Long, remember long was an 8-byte variable in C++, and that could hold a larger range of values, integer values. But when you specify that, you have to put an L at the beginning. So that L could be a capital L or a lowercase l, doesn't really matter. But you have to put an L. Otherwise, by default, any number that you write, C++ compiler assumes that it's an integer. So if you don't put this L at the end for a long variable, um, compiler is going to complain, saying that I cannot fit this into an integer. So by default, again, everything is an integer, so you have to put an L if you want to make it a long variable. Floating types, floating point types, float. Remember, it's a 4-byte floating point number, so 2.75. F, again, that F indicates that it's a float. By default, every floating point number is assumed to be of type double. That's why I'm saying double. Pi is equal to 3.14159. And finally, you could also use what's called a scientific notation to initialize a variable, where you say 2.56 e 60. That's essentially saying 2.56 times 10 to the 60. All right, so this e is referring to 10 here. It's 10 to the power of 60. So it's 256 e 60. That's called the scientific notation in C++. So let me just run this so that you can see the output of the program. Here it is. Let's wait for a while. Let's go to the terminal. Um, what I want you to realize is the following. Remember, the first variable that we had in this program was a Boolean variable. So it's a Boolean is valid, but I'm printing that, and what gets printed on the screen is 1. Remember, this is something that's kind of peculiar. It might seem peculiar. Instead of printing true, it prints 1 on the screen. And the reason for that is C++ is an extension of C, and C does not have a Boolean data type. So we'll talk about this later on. But in C, any zero value is considered to be false. Any non-zero value is considered to be true. When C++ added this Boolean data type, they kind of wanted to be backward compatible to C. That's why when you declare a Boolean variable and assign it to, assign an initial value of true, is you are essentially assigning a 1 value to it, saying that this is true, right? And when I make it false, and let me make it false and run it again, so you'll see that we'll see 0 on the screen because uh, any non-zero value is true. As you can see, it is 0 now. So any false is 0, true is any non-zero value. So let's look at the other values. So letter A, as you can see, it gets printed. Short value gets printed. Integer also gets printed correctly. Long also gets printed correctly because we have the L at the end. So the compiler knows that this is a long number, 8-byte integer. And E, float, double, which is 3.14, 159. And here's the scientific notation. That's why it's printing it in the scientific notation on the screen. So this plus 60 means it's 10 to the plus 60. I mean, we'll probably not be using this scientific notation in our programs in this course, but it is also good to know that something like this exists, so when you see it somewhere else, that you don't get confused. Sometimes when you write C++ programs, you would like to know the minimum value that can be represented by this basic data type or the maximum value that can be represented by this basic data type. For that, I've implemented an example called ex2.cpp because there are defined constants in C++ that you can use to learn the minimum and maximum values that you can represent with a basic data type. And they are defined in C float. So for character, it is character min and character max. So the minimum value that you can represent with a character data type is character min. The maximum value that you can represent with a character is character max. And that applies to every other basic data type that you see. For example, for integers, it is integer min, integer max. For doubles, it's dbl min, dbl max. Long is long min, long max. So every other, basic data type that we have seen have a defined constant that comes from the C float library that you could use. Let me just print it so that you see that the range of values that you can represent, store um, using these basic data types is exactly what I told you that what they were. So character is, minus 128 to 127. Long or integer. Remember, long and integer are both 4-byte integers. So it is like minus 2 billion something to 2 billion something, positive 2 billion something. And with long long, which is an 8-byte integer, you could represent a wider range of integer values. And for doubles, this is the range of values that you can represent a floating point number. And floats, you can only represent up to 10 to the minus 38 or up to plus 38. So when you use a 4-byte floating point number, you can only represent a smaller range of floating point numbers. When you use doubles, you can represent a wider range of floating point numbers. That's why we will only be using double in this course, integer, character, and boolean. That's it. That's all we are going to use in this course. C++ has a size of operator that you can use to learn the amount of space that any particular data type uses in memory, occupies in memory. So what I did in this example, which is example 3 in data types, is I printed out the amount of space that each of these basic data types occupy in memory, right? Remember, it's an operator, which means that the compiler actually computes the amount of space that each of these basic data types occupy in memory at compile time and inserts it in there. So it's not a runtime thing. So here is the program. I'm going to print it. So size of boolean, size of character, size of short, and they should come up. They should come up 1 byte, 1 byte, 2 bytes, 4 bytes, 4 bytes, 8 bytes, and so on. So remember, this we already talked about this, but let me just show you that that's really the case. So boolean and character is 1 byte, short is 2 bytes, integer and long are 4 bytes. Long is 8 bytes, float is 4 bytes, and double is 8 bytes. So that's why that's the number of bytes that each box occupies. So you could think of it as a box with a certain capacity. So character and bool are boxes that small boxes. That's why you can only put a certain range of values into these boxes. But as we go down, like until long, the size of the box gets bigger. So that's why we could put bigger values into these boxes. Similarly with double. So double is 8 bytes, so you can put larger values into this box. But this is an operator. Size of is an operator that you should be using if necessary, of course. C++14 added the auto keyword to the language, which is used for local variable type inference, where the type of a variable is automatically inferred by the compiler based on the type of its initializer expression. So look at the example in here. What I am saying here is valid is equal to false, but instead of declaring the type of this variable as boolean or bool, I'm just saying auto. Because this is a false that I'm assigning to the variable, the compiler can automatically infer that the type of this variable is a boolean. So by putting auto in here, I'm asking the compiler to put the type declaration itself, because the compiler can easily infer that type from the initializer expression. This helps reduce the boilerplate code and makes the code more concise and readable. Of course, for the basic data types that I have here in this example, which is example 4, this doesn't make much of a sense maybe. We're saying we're initializing a character in here. I could have easily said character instead of saying auto, because it's the same thing. Because like I said, when you put auto, you're basically saying, here's an expression. Hey compiler, here's an expression. So just infer the type of this variable from the initializer expression, which the compiler can easily do. It is a character. This is a integer, as you can see. And this is a long, because I have L at the end of this integer. So it's a long. It's a long, type. This is a float because I have F at the end of the initializer, and this is a double because I don't have F at the end of this initializer. So basically, for each of these basic data types, the compiler can automatically infer the type of the variable. This comes really handy when the type of the object that you have to initialize gets really complex. Of course, we don't have many examples that I can show you where auto is, useful because these are very basic programs. But as you become more proficient and advanced programmer in C++, you will see the benefit of putting auto instead of just specifying the actual type of the variable. Let's now look at string literals. String literals or strings in C++ represent a sequence of characters. Strings are not basic or primitive data types, but are objects in C++. So far, all the data types that we have seen, integer, character, whatever, they were all basic or primitive data types. But string is an object. So think of an object as a black box with data inside and associated behavior, which you'll be calling them methods when you take 211. So I don't want to go into the details of what an object is, but imagine an object is a black box that stores some data and has some methods in it that manipulates the data that's actually stored within the object. So here's an example where I declare a string and use some of these methods. So this is in all 3 string literals, example 1, and here's that code. So if you look at it, I'm just declaring and initializing a string, and the string is John Doe. Remember, every string in C++ must be enclosed within 2 double quotes, and they have to stay within the same line. So you cannot initialize it like this. This is not possible. So you cannot have a string that starts on one line and it ends at another line. This is not possible in C++. As you can see, as soon as I do that, the compiler is warning me that by underlying it with red underline characters, saying that this is not possible. This is an error. You cannot do that. So this has to be on the same line. Now, I declare and initialize the string and then print it on the screen. I can just use cout name, and that's going to print these characters on the screen. Then what I do is I am using some of the methods that are available within this string object. So length is one of them. And the way to invoke one of the methods of the object is to say the variable name, which is name, then use the dot operator. So it's dot. Then you're basically saying, I would like to invoke now a method inside this object, and that method is length. So it is one of the methods inside a string. There are others that you'll see later on when we cover strings. So name.length is going to return the number of characters within the string. And let's just count it. This is 4. Then we've got a space character, which is 5. Then we have the last name, which is Doe. That's 3 characters. If you add them up, that should be 8 characters. So name.length should return 8. You could also refer to individual characters of the string using the square bracket operator. All right, so you could say square bracket 0. So the first character has an index of 0 and the last character has an index of 7. So what I'm printing in here is name 0, which is the first character, which is J, and name 5, which is D, the first character of the last name. So let me run this thing so that you can see that that's exactly what we're getting. So here is the code. Let's go to the terminal and let's go to the code and see them one on top of each other. Here's our name. So we print name. As you can see, John Doe appears on the screen. Then it prints the length of the string, which is 8 characters. Then name 0, which is the first letter of the first name, and then name 5, which is the first character of the last name. Of course, we'll see that this is an array of characters. It's stored as an array of characters within the object, and the first index of an array is 0, and the last index is the length of the string minus 1. And if you try to access a character that does not exist, your program is going to crash. So I cannot make like -1 in here. -1 is not a valid index. Similarly, I cannot make 10 in here because 10 is not a valid index for this string. So the indices have to be between 0 and 7 because you have 8 characters. So the first character is an index of 0, the last character is an index of 7. So all the indices that you use to refer to individual characters of the string has to be in between 0 and 7, of course, for this string. So let me just change it back so that I print the first character of the first name and the first character of the last name.